everyone. My name is Srinath Thube. I am a software developer at IBM. I'm excited to present our work demonstrating multi-agent collaboration via agent-to-agent and model context protocol and an IT incident response case study. This work was done in collaboration with my lead author Vaibhav Dubey, who is the technology lead at Equinix. Please note that this is a personal research project and not affiliated with IBM or Equinix. In this demo, we will showcase how multiple LLM agents can collaborate using agent-to-agent protocol and how they can leverage external tools through model context protocol to perform complex tasks such as IT response, IT incident response. Let's get started. This is our overall demo project architecture. We have used three LLM agents. Before going forward, I would like to give you a little bit brief history about LLM agent evolution. So when the LLM exploded, everyone wanted to use it, and then agent was the best way to use the LLM feature. And when it started with a single generic agent which has a lot of capability. It was doing everything like planning, reasoning, or executing, even interfacing with the tools, and it was good. But when you have that much responsibility, then it was not flexible. Or when we wanted to scale it more, then it had its limitation. That's why now we are moving to the multi-agent system where each agent has its own role, own capability, and it is focused on the one task or a limited set of tasks, and it can outperform the generic agent. When we talk about the agent, and the two problems uh, we see. First is like uh, for agent to have the that much capability, or uh, to have the reasoning and have the capability, it needs data, real time data, so that it can. So agent needs to interact with the web search or internal tools, or it needs to query the API. The traditional method, which is like REST, REST is not that efficient in the agent case. So that's where the MCP, which is model context protocol, which is more context aware, and it does have multiple steps in it. It is real time. It comes into the picture, and it provides that capability, uh, uh, the tool usage capability and the real-time interaction with the API capability to the agent. The second problem is if we have multiple agents, how they will communicate each other. The REST API is useful for our conventional software, but it is not efficient or optimum for the agent to agent communication. That's where the A2A protocol, which is recently released by Google, uh, helping helping to resolve or fill that gap, and it provides more context-rich communication between the agents. So in this our demo, we are trying to bring these two protocols together, MCP for tool usage and A2A for communicating between different agents, and to showcase how they can collaborate with each other to perform a real world complex task such as IT incident response, and where each agent has a clear role like incident coordinator, diagnostic agent, and resolution agent, and they perform their own duty. So so when you see this architecture, we can start with the production system. It can be anything, either Kubernetes cluster or VMs where application is deployed. So whenever we have something issue, then that incident is created from the production system. It goes to the incident coordinator agent. The coordinator agent analyze it and forward it to the diagnostic agent. A diagnostic agent use the MCP protocol or MCP tools, such as log analyzer, knowledge base, system monitoring, to to get the more context about that particular incident, to gather more information, and create a diagnostic report. Then that report is forwarded to resolution agent. Resolution agent takes the action using that report, and it can take the action using the MCP protocol again, and it can use the deployment tool to correct the production system. Correction means like it can increase the number of pods or change the configuration of the Kubernetes cluster to solve the incident. Now I'm going to hand over to Weber to show you actual code demonstration and how we can showcase the IT incident resolution. Over to you, Weber.
Thank you, Srinath, for introduction and a very good overview of our project, which is multi-agent collaboration system with Google's A2A protocol for agent-to-agent communication and MCP protocol. This multi-agent system is implemented with IT incident response use case study, as Srinath clearly explained. So I will be going over the brief demo about this whole system with a simulation of some IT incidents, and how does this agentic behavior happens, and how these incidents get resolved we'll see this briefly here. So this is a typical Python project structure. You can see the agent directory where three agents are declared here: a coordinator, diagnostic, and resolution agent. Then there are protocol implementation here, A2A, MCP. There is a simulation data here added for incident, log, and system. And the MCP tools are defined under here, tools directory, which are log analyzer, knowledge base, deployment related activities, system monitoring, ticketing, access. So I will be running this system now, and it will simulate an IT incident. It will take actions based on the incident, and will run through the logs and explain you what it did. So I have executed the system. It is going through. So you can see the system has been initialized with all the MCP tool registration and the session establishment. The new incident got created, that simulated incident. Okay, and you can see the coordinator agent has this task, and this is how the A2A task and message looks like as part of the protocol. So this is what the incident got created by the coordinator agent, the very first agent when the incident got locked to it. So it used a MCP tool for ticketing system. It created a ticket and logged the incident. The incident is database connectivity issue in production. Status is investigating, severity is high, and these all systems, these app servers and DB servers were impacted. Okay, and this coordinator agent, the very first agent, it assigned this to the diagnostic agent to analyze this incident. And now the incident uh, and the message goes to the diagnostic agent. This is how the E2A protocol comes into picture, and you can see how the message and task has been passed to the diagnostic agent. So diagnostic agent does its work, and this is what the diagnostic report generated by the diagnostic agent. So the root cause identified for that database issue is network latency spike between application and database server. Okay, and the confidence for this RCA is 85%. So pretty good. And the evidences along with that, why this diagnostic agent was able to figure out that is the RCA. These are all the evidences he has put together. Uh, and some of the recommendation actions you can see here. Uh, and after it does its work, the message goes to the implementation or resolution agent basically. So resolution agent takes action based on the diagnostic agent's task and message, which is passed to the resolution agent. This is again A2A protocols message, how it goes to the resolution agent, you can see. And during the resolution phase and even the diagnostic phase, you can see a lot of MCP tools being called here. In this case, particularly for resolution agent, it is calling the system tooling, where it takes the action into the production system directly to change the configuration and other stuff. So you can see the resolution status here. So the completed and actions taken are mentioned here. Applied action is like monitor system for additional error patterns on these particular app servers and DB servers where issues were there. Reviewed recent system changes and deployments on these two servers. Temporarily increase the resources for affected services on those server, and verification is successful. And test cases and test execution also perform. You can see here load test with simulated traffic, and all the testing and sanity is also done. So with this, we can see the final report of this incident is logged with the resolution and its notes. And this is where the complete demo is done for our IT incident response system. It is completely multi-agentic behavior with A2A protocol and MCP protocol, both protocol working together a collaborative way to solve the incident in pretty complex production environments. Thank you.